Section 3, we're still in our very exciting learning target 2, but now we're on to part C, which this time, instead of being given 2 points or getting the points from a graph, we get to find the points from a table, which I think is pretty obvious because it's right there in the table. So we're still going to write a linear equation, but this time those 2 points are going to come from the table. So pause the video and write these 5 steps down for me. So we're going to start with this table here, and we're going to use those 5 steps that you just wrote down. So the first step is to identify 2 coordinates. So again, I think this is a lot easier because they're right there in front of us. It doesn't matter which 2 you pick. So I'm going to pick 2 weeks and $149 saved. And let's pick the first one and last one just for fun. 8 weeks and $341 saved. So write that down. 2. There's my first coordinate, and my second coordinate was 8 and 341. Step 2, solve the slope. So by now you're probably experts, or you probably could make this video on how to solve slopes by now. But remember, slope is y2 minus y1 over x2 minus x1. So x2 here, in this case, is 341. We're going to subtract y1, which is 149. And then x2 is 8, and we're going to subtract that from x1, which is 2. So 341 minus 149 equals 192. And 8 minus 2 is 6. So 192 divided by 6 is 32 over 1. Or as we're going to write it in our equation as just 32. Solve for the y-intercept. So now on step 3, we're going to have to go back to how we did part A, since there's no graph to identify it. You probably could work it backwards in the table, and I know we've done that before. I just think it's faster if I use the actual points here. So I have 2 and 149, and I'm going to plug that into the equation and just solve. I prefer algebraically because I can manipulate the equation to make it work for me. Okay, so y is 149. My slope is 32. My x was 2, and my y-intercept is b. So 149, 32 times 2 is 64, add b. Again, we're looking for this b, this y-intercept. Subtract 64, because I need to get rid of the 64 on the side with the b. So 149 minus 64 is 85. So my y-intercept would be, if I wrote it as an ordered pair, 0, 85. Again, if you want to work it backwards, you would have found that same thing in the table. So last step, I think is the easiest step. We're just going to plug it in to the equation. So y is my variable that changes. So it's y equals, my slope was 32. My x is my variable that also changes. And I now know that my y-intercept is 85. So when you check, it's kind of up to you. You can check with points that you didn't pick, because all these points should be able to work in the equation, or you can pick 2 points that you have already used. So I'm just going to use the same 2 equations I used, or same 2 coordinates I used at the beginning. But again, if you want to use another coordinate, you are welcome to. They will work. All right, let's plug it in here. So my y in this case is 149. I'm take 32, which was my slope, times my x value, which is 2, and add the 85, which I believe is my y-intercept. So I'm going to take 32 times 2, which is 64, add it to 85, and when you add those, you do get 149. So 149 does work. So that first coordinate point works. Let's check the next one. So my y in this case is 391. We're going to take 32 times the 8, because that's my x value, and add 85. So 32 times 8 is 256, add 85, and quickly do it in my head here. or you can check a calculator. It is 341. So both the points that I picked and both the points in that table do work. So I guarantee that this equation is the equation for the table. Next one, this one, again, we're just going to pick 2 points. Let's go with the middle two this time, just for fun. Okay, so I'm going to pick these 2 points. So 4 hours and 295 miles driven, and 5.5 and 377.5 miles driven. Solve. Again, I'm just going to use the first one as my set 1 and my second one as my set 2. So we're going to solve for the slope. The verb there is solve. So y2 minus y1 over x2 minus x1. So y2 is 377.5. Y1 is 295. And we're going to go put that over x2, which is 5.5, minus x1, which is 4. So 377.5 minus 295 would be 82.5. And then 5.5 minus 4 is 1.5. And when I divide 82.5 by 1.5, I'm going to get 55 over 1, which we could just use as 55, which is a good sign because this is miles per hour. So I'm going the speed limit in this storyline because those miles driven in hours. The y-intercept, go ahead and pick whatever point you want. We'll just pick the first one. Again, you could work the table backwards if you want. I just like to solve algebraically here. So y, which is 295, equals my new slope that I found out was 55, times the x value, which is 4. And my goal is to get the unknown b at there at the end. So 295 equals 55 times 4 is 220, plus b. I'm going to subtract 220 from both sides because I don't want that on the side with the b. So 295 minus 220 is 75. So b, or my y-intercept, is 0, 75. Next step, write that beautiful equation. So y is my variables. My slope I found out was 55, x, and I just found out my y-intercept is 75. So I'm going to check using my 2 equations, or my 2 points I picked from the table, which is 295. Again, you can pick the other points if you wanted. I'll just keep consistent here and use the 2 points that I originally picked. So I'm going to plug in here y, which is 295, equals my slope of 55 times the x value in this coordinate, which is 4, and add 75. So 295, 55 times 4 is 220. Add the 75 at the end. That does equal 295. So I can guarantee that this point that I picked off the graph does work in this equation. Second one. So my y is 377. So 377 and 5/10 equals 55, which is my slope, times my x value in this one, which is 5.5, plus 75, which is my y-intercept. So I'm going to multiply here 55 times 5.5, which is going to get me 302.5. Add it to 75. So I get 577, yep, 377.5. So both of these work perfectly, which guarantees that both of these points that are in the table, this is the linear line that works for it.